Humanity has always looked at the stars and wondered, are we alone? But the answer lies across distances so vast, they defy comprehension. Our nearest neighbor, the Alpha Centauri star system, is 4.37 light-years away. With today's fastest chemical rockets, a trip there would take 30,000 years. That isn't a mission, that's history. If we want to reach the stars in our lifetime, we don't need a bigger rocket. We need to rethink space travel entirely. Enter Breakthrough Starshot. It is one of the most ambitious engineering projects ever proposed, a Silicon Valley approach to interstellar travel. The goal, to reach Alpha Centauri not in millennia, but in just 20 years. To achieve this, Starshot relies on a technology trinity, 3 innovations working in perfect unison. First, the vessel itself. Forget massive spaceships like the Enterprise. This is the StarChip. Thanks to the miniaturization of Moore's law, this gram-scale wafer holds everything a probe needs: cameras, photon thrusters, a power supply and navigation equipment, all on a chip, just a few centimeters wide. Second, the propulsion method. The StarChip is attached to a light sail. It's about 4 meters wide but only a few hundred atoms thick. It is designed to be incredibly lightweight and nearly perfectly reflective. And third, the engine. But this engine doesn't fly with the craft. It stays here, on Earth. It is the light beamer, a massive ground-based phased array of lasers capable of generating 100 gigawatts of power. So, how do we get to 20% the speed of light? The mission begins in high Earth orbit, where a mothership releases thousands of these StarChips. One by one, the light beamer on Earth targets a sail and fires. For just a few minutes, the pressure of photons, literal particles of light, slams into the sail. This isn't a gentle push. The craft is subjected to 10,000 Gs of force, accelerating from 0 to 134 million miles per hour. That's 60,000 kilometers per second, or 0.2 c, almost instantly. Once the laser turns off, the cruise begins. The StarChip coasts through the vacuum of space for 2 decades. The journey is perilous. At 20% the speed of light, hitting even a microscopic grain of interstellar dust releases the energy of a bomb blast. To survive, the StarChip will likely need a sacrificial shield layer made of materials like beryllium. But for the survivors, the prize is waiting. 20 years after launch, they fly through the Alpha Centauri system. They won't stop, they can't. In a frantic flyby lasting just hours or days, they will snap close-up photos of Earth-sized planets like Proxima Centauri b, searching for signs of life. Then comes the final challenge, beaming that data back over 4 light-years of distance. It will take 4 years for the signal to reach us, where a receiver the size of the square-kilometer array will be waiting to catch the whisper of a signal. Backed by Yuri Milner and initially supported by giants like Stephen Hawking, this project is currently in a long-term research phase. With $100 million in initial funding, scientists are tackling the melting problem, ensuring the sail reflects 99.999% of the laser energy so it doesn't vaporize instantly. While a launch is likely decades away, perhaps the 2040s or 50s, Breakthrough Starshot is more than just a space mission. It's really the ultimate test of nanophotonics and wireless power transfer. And honestly, it is humanity's first serious attempt to step out of our solar backyard and become an interstellar species. The stars are waiting.